this is Mrs. Percival, and today I'm going to be talking to you about how you're going to run your statistical analysis. So we're going to be walking through a t-test, and a t-test is good when you have two different groups of data and you're trying to compare the data and find out whether or not the two different groups of data are different enough to say that the experimental variable actually had an impact. If you remember correctly, you could flip a coin 10 times and you might end up with 6 heads and 4 tails. Does that mean that the penny was fixed? Does that mean that something fishy was going on? You and I would probably say, no, it's just due to random chance. So there can be differences in data that are not significant. The t-test is going to be looking at two groups of tests and telling us whether or not our data is significant enough for us to say that our hypothesis was supported. We can never say that everything that happened within our two groups was due to the experimental variable we applied. But we can suggest that yep, it seems significant enough that I'm going to say I think that there is something going on here. So let's look at what a t-test is actually testing. A t-test is looking at your data. It's pretty much calculating the average like it is over here. So this would be two groups of data. Here's an average for group 1 and here's an average for group 2. You can see that most of the data would be expected to be found in the main part of the curve. And most of the data in group 2 would be expected to be found in the main part of the curve. Now, some overlap is happening here. That's totally okay. But is the overlap due to the fact that these guys are not different enough? Or is it due just to the fact that there happened to be some overlap in the data or some random chance that's working? And so this right here we would call medium variability. So there's differences between the two groups. We can tell that there are differences, but as a scientist, I wouldn't say those differences are good enough to say that I'm sure my experimental variable is different enough. In this one, you can see that there's lots of overlap. So I would definitely not say that my hypothesis was supported. They're just too close to each other. They look too similar. There's too much overlap. And so then I would have to accept my null hypothesis. My null hypothesis that states the experimental variable did not impact the data. And it's pretty much saying that all of the differences are probably just due to random chance. In this case, this is good data. It's okay for there to be a little bit of overlap, but most of the data is completely separate, which means that this data is very different from this data. That means that probably the two groups are statistically significantly different. Okay, so I'm not going to ask you to chart these types of curves or to look at this on a graphic basis, but what I am going to ask that you do is I'm going to ask that you let Excel do your math for you. So the first thing that you want to do whenever you're doing a statistical analysis is you want to get your average. So there's two different ways that you can get your average. The first way to get your average is to go up here to the function key. Now this function key, if you look at it, it's going to give you all sorts of really interesting things that it can do for you quickly and easily. So I'm going to go ahead and go to my function key. Oh, that's not what I wanted to do. And I'm going to click average. Okay? I'm not quite sure what just happened there. I think it still summed it. Okay, average. So if I click average, it automatically is going to guess that I want to average the data on top. That's what I want to do. Good job. So I'm just going to hit the enter button. I'm going to show you also how you can do it the long way. if I hit the equals button, it tells Excel that I want to do something math related. And I want it to calculate the average. Okay, and then I put in parentheses, and I highlight the data that I want it to average, close parentheses, and I hit enter. Both of these are different ways that you can get Excel to calculate the average for you. Okay, now the next thing that I'm going to show you how to do is how to calculate a t-test. Okay, so really what Excel is going to do is it's going to track these curves for you and it's going to spit out a number. And I'm going to tell you how to read that number and tell whether that number is important or not. Okay, so we're going to do what's called a t-test. And in order to do that, I'm going to hit the equals button. And guess what? I'm just going to write t-test. Okay? And I'm going to put in my parentheses and see how it says array 1, array 2, tails, and type. Array 1 just means set of data 1. So I'm going to take this, I'm going to highlight it, and then I'm going to put a comma to separate it from array 2. So I'm going to highlight this, comma. Now, it says how many tails do I have? Well, in this case, it says if the pH is decreased from 8 to 6, the heart rate of dyspnea will increase due to stress. So in this case, I think that the heart rate is going to increase. So I think that my experimental data is going to move in one direction. Okay? Sometimes you don't know. You just think that the heart rate of the dyspnea will change. Okay? In fact, so in this case, I'm actually going to change my hypothesis to say that, oh, that's not what I wanted to do. We're just going to go ahead and put in 2, and then I'm going to put in, this is going to be a type 2 t-test. You're doing a type 2 t-test, and I'm not going to go into a whole bunch of details about what the other types are. Pretty much, a type 1 is when you have, this would be the same person that you're testing, and the same dyspnea at a pH of 6 had a heart rate of 180, and the same dyspnea at a pH of 8 had one at 150. So these guys are the same organism that you're looking at, but we picked different organisms. So, but we have the same number of data points for each experimental variable group. So that's a type 2 sample with equal variance, equal numbers of samples taken, and they're not connected to each other. Okay, so that's the type 2 t-test. So I'm going to go ahead, put my parentheses in, and it's going to spit out a number. Ooh, this number is really good. If the number is less than 0.05, then you reject the null hypothesis because your hypothesis is supported and there is a statistically significant difference in your data. Okay? So this number is definitely less than 0.05. Okay? And that means that I can say my hypothesis is supported and I'm rejecting the null. The null, remember, says the experimental variable did not impact the data. I reject that. I think it did impact the data. So I'm going to say my hypothesis was supported. Okay? Now, if my t-test value was, say, 0.15, that is not less than 0.05. Okay? Pretty much what I'm saying is that there's a 15% chance that the differences between my two groups is just due to random chance. Okay, so there's an 85% chance that my two pieces of data are statistically significant, right? You might think 85%, that's pretty good. That's like a B. But in science, no way. We only accept 95% or better. So think of scientists want an A, a solid A, 95% or better certainty that the two groups are statistically different. So this would indicate that the value for the t-test is greater than 0.05. This indicates that the data is not statistically significant. The null hypothesis is accepted. Okay? So this number right here would indicate a set of data that's like this. You might say, oh, well, it looks pretty good. Remember, 85% sure that they're different, but I'm still 15% sure, not sure. And 15% uncertainty isn't good enough for a scientist, okay? But this number, so less than 0.05, this is great data. This data says, wow, I'm really, really sure that my two groups are totally different, which means something serious is going on here, okay? So that's how you run a t-test using Excel, using two different groups of data. All right. I hope that this was helpful and that you enjoyed the tutorial. If you have any other questions, please come and see me, and I'm happy to help you out.